guys, welcome to the brand new course by Uplatz on API. This is the course where we have designed the basics of API for beginners. So by the end of this course, you will understand what's an API, what are the different components of an API, what are the important concepts of API, how to design APIs by using different examples. So as we all know, API is the acronym for Application Programming Interface, which is a intermediary software that allows two applications to talk to each other. Each time you use an application like Instagram or Facebook or Twitter, or check the weather on your phone, you are basically using an API. So when we use an application on your mobile phone, the application connects to the internet and sends data to the server. The server then retrieves the data, interprets it, and performs necessary actions and sends it back to your phone. The application then interprets that data and presents you with the information you wanted in a way that is readable. This is what an API is. All of it happens through API. So a very suitable example is a waiter in a restaurant who acts as the API between the customer and the chef. So let's begin our first session, Introduction to APIs, where you will learn about what is an API, when did API start, how did API start, what are the APIs used for, and what are the reasons that we use APIs.
So let's begin. Introduction to API. So if anyone wants to learn about APIs, so here we are going to discuss about these basic concepts. So as we all know, in a nutshell, API stands for Application Programming Interface. So APIs have been in use from a long time. So today we have advanced APIs, different types of APIs and all. So APIs are the small piece of code that make it possible for digital devices, software applications, and data servers to talk with each other. And they are the essential backbone of many services we can rely on. So today, almost every application is API based. Nobody will enable the users to allow the access directly to the web servers. Every request is sent through the APIs. So it's an essential backbone of many services we can rely on today. So an easy way to understand the definition of an API is to think about the applications that you use every day. In an internet-connected world, web and mobile applications are designed for humans to use. So in an internet connected world, web and mobile applications are designed for humans to use, while APIs are designed for other digital systems and applications to use. Websites and APIs both do the same things, like they return data, they return some content, they return some images, video, or other information, but APIs don't return all the details that are needed to make things look pretty for the human eye. You only get the raw data and other machine readable information needed behind the scenes to put the resources being delivered to work with very little assistance from a human. So every system is integrated with the API. So knowingly or unknowingly, we use API in a lot of places. Knowingly or unknowingly, we send the requests to the system through the APIs. So when a client sends a request to the server, he's actually communicating with the API. The API in turn communicates with the server, and the API gets you the required information in the required format. So this situation is analogous, is similar to the restaurant where the people order the food to the chef, to the waiters, and the waiter communicates with the chef. So the customers are the clients here, and the chef is the server. And waiter does that great work of the APIs. He communicates with the chef and he gets the dish you ordered for. Sometimes if the dish is not available, he will get you the message that they don't serve those dish. So similarly, when you request for something that is not written in the server, you will get some error messages. So then what is API integration? API integration is a Google search term. The whole reason APIs exist is to support integration. API integration is simply the connection between two or more applications, programs, services, or systems using APIs. Applications use APIs to send and receive data and content between each other. So when did APIs start? Web APIs got their start by putting the commercial in .com, powering the commerce startups looking to change the way we do business on the web. They took advantage of this new medium to make products and services available to customers via a single website. And as they worked with partners, they sought to automate much of the commerce that was powering the web and included juggernauts like Salesforce, eBay, and Amazon. In 2004, a shift in the API landscape began to emerge as a new breed of API providers started to pop up, offering ways to share information with local and global social networks led by the likes of Facebook and Twitter. The strong start in commercial and social applications, APIs continued to grow as everything moved to the cloud. It became much more mobile and provided the foundation for next generation devices. To get the full scope of the history of APIs, we will go through the next concept. So, where are web APIs used and what are the uses of web APIs? So the APIs can do lot of things. The APIs power desktop applications. APIs are behind most web applications. APIs make mobile applications possible. APIs connect everyday things like automobiles, doorbells, the wearable devices. APIs define the networks or the information passed between applications, systems, and devices. APIs connect devices to the internet. APIs are the integrations for no-code solutions. So APIs help us access the data we need to get the work done and do the tasks on a daily basis. Whether we are a business user, a student, or using an application just for fun. APIs make it possible to integrate different systems together, like customer relationship management systems, databases, or even school learning management systems. APIs help different departments, teams, and groups become more agile. APIs help organizations, schools, government agencies, and non-profits strengthen the relationships with other organizations, research institutes, and agencies. So APIs work by sharing data and information between applications, systems, and devices, making it possible for these things to talk with each other. Sometimes the easiest way to think about APIs is to think about a metaphor and a common scenario, as we had discussed in the few minutes before about the restaurant. So the customer talks to the waiter and tells the waiter what he or she wants. The waiter talks to the chef in the kitchen. The kitchen does their work, creating the food, and then the waiter delivers the food back to the customer. So here the customer is like a user who tells the waiter what he or she wants. The waiter does the task of this API, receiving the customer's order and translating the order into easy to follow instructions that the chef then uses to fulfill that order, often following a specific set of codes or input that the kitchen easily recognizes. The kitchen is like a server that does the work of creating the order in the manner the customer wants it. So then why should we use APIs, and what are the reasons to use APIs? So almost there are many reasons for why should we use APIs, but the best answer when we did the research with developers and professionals and why they choose to produce or consume APIs. So the frequent answers are integration with internal and external systems. So this is one of the top reasons developers use APIs. That is to integrate one system with another system. For example, if you want your customer relationship management system to integrate with your marketing automation system, you could use an API to enable two systems to talk to one another so that you automatically send a marketing email when a sales representative adds a new prospective customer to the CRM. Then adding functionality of internal and external systems. Another common reason that developers use APIs is to add or enhance functionality of internal systems as well as external systems. For example, if you have an internal system that tracks vacation days for managers, you might use an API to allow employees to request days off from their email. Then adding functionality for customers. Sometimes when you add or enhance functionality, it's about improving customers' experiences and helping them interact better with your organization. For example, if you worked for a food delivery company, you might use an API to automatically notify customers when their meals is approaching their house. Then to increase the development of the system and software. APIs allow developers to code and deliver functionality as microservices. instead of big monolithic applications. By breaking this functionality, developers can actually speed up software development and system development by eliminating dependencies and reducing the overhead involved in code reviews, testing, and more. Another way that APIs help accelerate development is by allowing front-end and back-end teams work in parallel. In other words, a front-end developer can work on creating the front end of a system, what users and customers see, while a back-end developer can work on the underlying system, what users and customers do not see. Then improving the testing tasks. So APIs can help improve software and system testing by allowing quality engineering teams to separate tests for front-end components, the parts of software that users see, from tests for back-end components, the parts of software that users don't see. API health, quality, and performance can also be checked using automated testing. Then reducing software development costs. One of the biggest ways APIs can reduce software development costs is by allowing developers to build reusable components. For example, a backend developer can create a system that serves information about customers, including their names, email address, recent product purchases, etc. Then other developers across the organization can use APIs to grab that information and track payments for finance and accounts payable, help customer service resolve problems faster, or even create recommendations for marketing campaigns. APIs can also help reduce software development costs in a number of other ways, such as reducing architecture complexity and reducing the effort required to make changes to systems. So one of the biggest ways APIs can reduce the software development costs is by allowing developers to build reusable components. For example, a backend developer can create a system that serves information about customers, including their names, email address, recent product purchases, etc. Then other developers can use APIs to grab that information and track payments, help customer service resolve problems faster, and even create recommendations for marketing campaigns. APIs can also help reduce software development costs in a number of other ways, such as reducing architectural complexity and reducing the efforts required to make changes to systems. Then reducing operating costs. So APIs can help perform a number of functions that may have been done by humans, from pulling reports to sending emails to abstracting the data from one system to share with another system. APIs can help reduce operating costs in many other ways. Examples can be automatically starting up and shutting down manufacturing systems, creating schedules for workers, or even reducing the number of people who need software license. Next, let's see the different types of APIs. So we will see internal APIs, external APIs, partner APIs. So it is the way to categorize the APIs by the objective of who has access to them. Okay, so APIs can be accessed by different people. So if we categorize with this respect, so internal APIs are the APIs that are private and only used by the team, department, company, or the organization. External APIs, also known as public APIs or open APIs. They are publicly available to anyone, for anyone to use. Partner APIs are private and shared only with specific integration partners outside the organization. Then what are the different architectures of APIs? So when it comes to API architecture, there are a number of styles. So some architectures are older, some architectures are new, and every architecture has a place in the API ecosystem. Defining the architectural styles broadly. So here we will see few definition of different architectures. The first and very popular architecture is REST API. So REST is an acronym for the representational state transfer. REST APIs rely on a few guiding principles, such as client-server structure, simple uniform interface to communicate across systems. They have stateless operations and others also. So representational state transfer APIs are the modern APIs. They follow the modern architecture. They use HTTP protocol for the communication purpose. They are simple and they are stateless. Then we have Webhook. Webhooks are event-based, and simply put, they are automated messages sent from one system to another system anytime an event occurs. Webhooks are even referred as reverse APIs as a concept to check for changes in data. Next, we have SOAP APIs. So SOAP is the short form for Simple Object Access Protocol. So SOAP APIs are more structured and formalized than other APIs. They are reliable and trusted, but they are slow than other APIs. So SOAP APIs use XML-based messaging protocol, which is known as WSDL, the Web Service Description Language, which includes the envelope, header, and body tags as required by the endpoint. So all these are the very important API architecture styles. So next is some limitations of producing APIs and consuming APIs. So people produce APIs. So it can be an external API, internal API, partner API, a secure API, insecure API, implementation API, or the proxy APIs. So this is known as API production. Then what is consuming the APIs? Consuming the APIs can be any end user who wants to access that API. So when it comes to building APIs, there can be a number of challenges and obstacles that developers face. So the limitations are complexity. While the concept of APIs is relatively simple, the implementation of APIs can be extremely complex. Many individuals who consume and produce APIs find complexity to be a major obstacle. Then time. The number one obstacle for API producers, as well as an obstacle for many API consumers, is lack of time. Building and consuming APIs can be a time-intensive effort, depending on what you want APIs to do or how you use them. Then documentation. The number one obstacle for API consumers is documentation. API documentation refers to the information the API providers provide to API consumers to help them understand how to use APIs. So documentation is a part of API portal. Then the API portal should also consist of different sections. Section for providing the feedbacks, section for requesting the API access, section for registering the applications, section for entering the credentials, and very importantly, section for testing the APIs. So these things play a very important role. Then knowledge. So many producers and consumers face this issue of lack of knowledge. In some cases, individuals working with APIs need deeper technical knowledge, while in other cases, individuals are technically adept, but they lack knowledge about the features of specific APIs. Then people. So time is closely related to knowledge. So lack of time is closely related to lack of time and knowledge. Many teams find it challenging to produce and consume APIs with their existing team infrastructure, and they need additional people on their team to expand their technical knowledge as well as expand the amount of time individuals can spend on API efforts. Then stakeholder prioritization. Stakeholders who have a stake in projects and efforts are often the ones who control the resources, staff, and funds that are allocated to projects. If stakeholders do not prioritize API projects, that can be an obstacle to consumers and producers alike. Then budget. For most people and for most teams, it takes a budget to produce and consume APIs. Sometimes that budget is spent on staff and training, sometimes on tooling, and some APIs require funds to use the API on a regular basis. Then sometimes unrealistic expectations. So some stakeholders, as we earlier mentioned, who have a stake in projects. So often these stakeholders don't have technical backgrounds and they're not clear about what they are trying to achieve with APIs. Or even worse, unrealistic about what it takes. Then leadership. It can be really hard for teams to work on something that organization leadership believes in or buy into. When leaders don't buy to APIs, projects don't get prioritized and they fall by the wayside. The lack of tools. Very few developers open up a blank notepad and begin coding. There are a lot of tools available to developers to help them code smarter, faster, and better. But not every developer has access to the tools. So it becomes an obstacle. So these are the limitations in producing and consuming the APIs. So looking for some real world examples of APIs. So we have knowingly or unknowingly have come across many APIs in our day-to-day life. So you can find APIs from many popular providers. So they can be Twitter APIs, Okta APIs, SurveyMonkey APIs, then Yelp APIs. So we have many websites as API directories. And one of the most popular API directory is Postman API network. So Postman API network provides a central place for both consumers and producers to easily discover, explore, and share APIs. So we will see how to browse the Postman API network along with the walkthrough. Before that, let's see some different types of APIs provided by the Postman API network. So it can be Twitter API, Imgur API, Okta API, SurveyMonkey API, Yelp APIs. So Twitter APIs allow you to do many different things like looking for specific users, looking up specific tweets, searching for tweets, filtering real-time streams of tweets, and much more. We will do this with an example. We will see how to use the Twitter APIs. Then Imgur APIs. They expose the entire Imgur infrastructure. In fact, using Imgur's API, you can do just anything you can do on imgur.com. Like you can find and share the funniest, most informative and inspiring images, memes, GIFs, etc. Then Okta APIs offer a wide range of APIs, including endpoints to authenticate your users. Challenge for factors and recover passwords. Okta also offers endpoints to configure resources such as users, apps, sessions, and factors. Then Yelp APIs. Yelp's Fusion API allows you to get the best local business information and user reviews of more than 1 million business in 32 countries. this session, we will know about the protocols. What are the roles of protocols in APIs? So people create social etiquette to guide their interactions. One example is how we talk to each other on the phone. Imagine yourself chatting with a friend. While they are speaking, you know to be silent. You know to allow them brief pauses. If they ask a question and then remain quiet, you know they're expecting a response and it is now your turn to talk. Computers also have a similar etiquette, though it goes by the term protocol. A computer protocol is an accepted set of rules that govern how two computers can speak to each other. Compared to our standards, a computer protocol is extremely rigid. For a moment, think of these two sentences. My favorite color is red, and red is my favorite color. People are able to break down each sentence and see that they mean the same thing, despite the words being in different order. Unfortunately, computers are not that smart. For two computers to communicate effectively, the server has to know exactly how the client will arrange its messages. You can think of it like a person asking for the mailing address. When you ask for the location of a place, you assume the first thing you are told is the street address, followed by the city, state, and lastly the zip code. You also have certain expectations about each piece of the address, like the fact that the zip code should only consist of numbers. A similar level of specificity is required for a computer protocol to work. So, protocol of the web. There is a protocol for just about everything, each one tailored to do different jobs. You may have already heard of some: Bluetooth for connecting devices and post office protocol, or IMAP for fetching the emails. On the web, the main protocol is the HTTP, better known by its acronym. When you type an address like http google.com into a web browser, the HTTP tells the browser to use the rules of HTTP when talking with the server. With the ubiquity of HTTP on the web, many companies choose to adopt as the protocol underlying their APIs. One benefit of using a familiar protocol is that it lowers the learning curve for developers, which encourages usage of the API. Another benefit is that HTTP has several features useful in binding a good API. So now let's discuss about HTTP requests. So communication in HTTP centers around a concept called request response cycle. The client sends the server a request to do something. The server in turn sends the client a response saying whether or not the server could do what the client asked. So the client sends a request to the server, which is known as the send request, and the server responds to the request, which is known as the return request. This cycle happens between the client and the server. So the client sends the server a request to do something. The server sends the client a response saying whether or not the server could do what the client had asked. To make a valid request, the client needs to have 4 things. One is the URL, one is the method, one is the list of headers and body. Computers have to be very specific to communicate with one another. So they need to include these things. So URL is a familiar thing to us in our daily life and daily use of the web. But we have to take a moment to consider their structure. In HTTP, a URL is a unique address for the thing. Which things get address is entirely up to the business running the server. They can make URLs for web pages, images, or even videos of animals or birds or anything. APIs extend this idea a bit further to include nouns like customers, products, and tweets. So URLs become an easy way for the client to tell the server which thing it wants to interact with. So APIs do not call them things, but give them the technical name resources. So the business make URLs for the web pages, but the APIs extend this idea to include nouns like customers, products, and tweets. So in doing this, URL becomes an easy way for the client to tell the server which thing it wants to interact with. The APIs do not call them things, but they give them the technical name resources. The next is method. The request method, it tells the server what kind of action the client wants the server to take. The method is commonly referred to as the request verb. There are 4 methods that are most commonly seen in APIs. They are get method, post method, put method, delete method. So the get method asks the server to retrieve a resource. The post method asks the server to create a new resource. The put method asks the server to edit or update an existing resource. The delete method asks the server to delete a resource. So for example, let's say there is a ice cream parlor with an API you can use to place the orders. You place an order by making a post request to the restaurant's server with your order details, asking them to create your ice cream. As soon as you send the request, however, you realize you picked the wrong style. So you make a put request to change it. While waiting on your order, you make a bunch of get requests to check the status. After an hour of waiting, you decide you have had enough and make a delete request. Cancel your order. And the next component is list of headers. Headers provide metadata about a request. They are a simple list of items like the time the client sent the request and the size of the request body. So have you ever visited a website on your smartphone that was specially formatted for mobile devices? That is made possible by an HTTP header called user agent. The client uses this header to tell the server what type of device you are using. A website's smart enough to detect and can send you the best format for your device. There are quite a few HTTP headers that clients and servers deal with that we will see in the later chapters. Then finally, the body. The request body contains the data the client wants to send the server. Continuing our ice cream order example, the body is where the order details go. A unique trait about the body is that the client has complete control over this part of the request. Unlike the method, URL, or headers, where the HTTP protocol requires a rigid structure, the body allows the client to send anything it wants. The four pieces, URL, method, headers, and body, make up a complete HTTP request. So URL is when you type http:// Method is when we use post, get, put, and all. Headers are the user agent, and body is the data. Now, we will discuss about responses. After the server receives a request from a client, it attempts to fulfill the request and send the client a response. HTTP responses have a very similar structure to requests. The main difference is that instead of a method and a URL, the response includes status code. Beyond that, the response headers and body follow the same format as requests. Then a very important component in responses is status codes. Status codes are the 3-digit numbers that each have a unique meaning. When used correctly in an API, this little number can communicate a lot of information to the client. For example, you may have seen this page during your internet searches where the response will be not found. the requested URL was not found on this server. So the status code behind this response is 404, which means not found. Whenever the client makes a request for a resource that does not exist, the server responds with a 404 status code to let the client know that resource doesn't exist. So please don't ask for it again. There is an array of other status in the HTTP protocol, including 200, means success, 201 for created, 500 for server error, 401 for unauthorized access, 429 for too many requests. After a response is delivered to the client, the request response cycle is completed and that round of communication is over. It is now up to the client to initiate any further interactions. The server will not send the client any more data until it receives a new request. So the response will have the structure like status code, headers, body. Status code, as I told you, it can be any status code depending on the response. Headers includes content type like JSON, Java, XML, text plain, CSV, and many others. Body is the data that we call it as payload that is returned back to the client. So how APIs build on HTTP? So far we have seen that HTTP supports a wide range of permutations to help the client and server communicate. So how does this help us with APIs? The flexibility of HTTP means that APIs built on it can provide clients with a lot of business potential. We saw that potential in the ice cream ordering example. A simple tweak to the request method was the difference between telling the server to create a new order or cancel an existing one. It was easy to turn the desired business outcome into an instruction the server could understand, which is a very powerful feature. The versatility in the HTTP protocol extends to other parts of a request. Some APIs require a particular header, while others require specific information inside the request body. Being able to use APIs obstacles on knowing how to make the correct HTTP request to get the results we need.